Happy morning, guys. Today we are going to look into a simple one mark numerical. A 5% solution by mass of one cane sugar in water has a freezing point 271 Kelvin. Calculate the freezing point of 5% glucose in water if freezing point of pure water is 273.15 Kelvin. So they had given freezing point of cane sugar solution is 271. Freezing point of pure water is 273.15. They're asking for the freezing point of 5% glucose in water. So two freezing points they had given. So we can use a difference in freezing point formula. So here, look here. So this is the formula we are going to use. That is del TF, that is equal to difference in freezing point, that is equal to KF. Molar freezing point diffraction constant into WB, weight of the solute, by molar mass of the solute by weight of the solvent. Again, difference in freezing point del TF is equal to molar freezing point diffraction constant by weight of solute by weight of solvent into molar mass of solute. Clear? So here we had written clearly, that is sugar is a solute here. So weight of the solute is 5 gram and weight of the solvent is total amount of solution is 100. So 100 minus solution minus solute, that is equal to solvent. So 100 minus 5, that is equal to 95 gram. And here molar mass of sugar is 342 grams per mole. And del TF, difference in freezing point of pure water and cane sugar, that is 273.15 minus 271, that is equal to 2.15 K. Now substitute these in this equation. That is del TF is equal to 2.15 K. KF we have to find out. Weight of the solute is 5 gram and weight of the solvent is 95 gram, and the molar mass of the solute, that is sugar in the case, that is 342. So this is for cane sugar. For glucose solution, the same thing. Del TF is equal to molar freezing point depression constant into weight of the glucose 5 gram divided by weight of the solvent 95 gram into molar mass of glucose here, that is 180. Here the molar mass of sugar is 342. Here the molar mass of glucose is 180. Okay, now we can divide the equation 2 by equation 1. That is del TF by we don't know the value of del TF here. That is what we have to find out for the glucose. But here we had find out the del TF value from the given values. So del TF by equation 2 divided by 1. This equation divided by this equation. Del TF by 2.15, that is equal to the equation as it is written, KF into 5 gram by 180 into 95 into upside down of this reaction of this equation. 342 gram per mole into 95 by KF into 5 gram. So del TF is equal to 342 into 2.15 by 190, that is equal to 4.085 Kelvin we are getting. 4.085 Kelvin we are getting. So the freezing point temperature of 5% glucose solution is actually this is a difference in freezing point now. So here already they had given the freezing point of pure water is 273 Kelvin, right? So from 273 Kelvin, if we reduce a difference of freezing point, we can get the freezing point temperature for 5% glucose solution. So 273.15 minus 4.05, that gives 269.07 Kelvin. So this is the required value here. That is the depression in freezing point or the freezing point of 5% glucose solution. Again, I'll come from the beginning here. Yeah, a 5% solution by mass of cane sugar has freezing point 271. Calculate the freezing point of 5% glucose in water if the freezing point of pure water is 273.15. So they had given the freezing point of cane sugar, 5% cane sugar solution and 5% cane sugar solution, freezing point of pure water. They asked us to calculate the freezing point of 5% glucose in water. So we are using the formula difference in freezing point is equal to molal freezing point depression constant. Del TF is equal to molal freezing point depression constant into mass of the solute by molar mass of the solute into mass of the solvent. Right? By applying this formula, we can first we are getting the equation for cane sugar. Right? First, this is an equation for cane sugar, and by the same way, we are getting the equation for glucose, and we are dividing the equation of glucose by equation of cane sugar, and thereby we are getting the del TF value, that is difference in freezing point. So from this value, we can find out freezing point of 5% glucose solution. This is one sort of solution. There is another sort of solution. Those who are not able to understand this type, we can go for another method. Look here. So depression in freezing point of a solution is given by del T is equal to freezing point of water minus freezing point of solution. Right. Here, freezing point of water is 273.15. Pure water they had given. Freezing point of cane sugar they had given. From this, we are finding out the del TF value of cane sugar, 2.15. Right. The molar mass of glucose and sucrose. Molar mass of glucose is 180 and sugar, sucrose is 342. So 100 gram of solution will contain 5 gram of glucose or 5 because it's a 5% solution. 5 gram of glucose or 5 gram of sugar. From this we can calculate the number of moles. That is mass by molar mass. So a number of moles of glucose equal to mass is 5 grams. Molar mass is 180. So 0.028 moles of glucose. And number of moles of sugar, sucrose here. Mass by molar mass 5 by 342, that is equal to 0.0146 moles. Number of moles. Now, mass of solvent is equal to total mass of solution minus mass of solute. Right? That is the mass of solvent. So, mass of solution is 100 gram, they had given, and mass of solute is 5. So, 100 minus 5, that is equal to 95 gram or 95.095 kg. Now, we can go for molality of sucrose solution. Molality of sucrose solution, that is equal to number of moles of sucrose by mass of solvent in grams or kilograms, right? They had taken in kilograms here. So molality is equal to number of moles by mass. So in the case of sucrose solution, 0.0146 is the number of moles of sucrose we calculated here by mass of solvent, that is equal to 0.095 kg. So that is equal to the molality is 0.154 m for sucrose solution, right? Now, modal depression freezing point constant, that is equal to Kf is equal to difference in freezing point by molality. Difference in freezing point here we had calculated, right? So del Tf is equal to 273.15 minus 270, that is a freezing point of pure water minus freezing point of solution. So 2.15. So we are applying this here, that is molality we had calculated here 0.154. So here Kf is equal to difference in freezing point by molality. That is difference in freezing point, that is 2.15 by molality, that is 0.154, that is equal to 13.97. Kf we had calculated as 13.97. Now, to calculate the difference in freezing point for glucose solution, difference in freezing point del Tf is equal to Kf into molality. Now, Kf 13.97 into m molality. Molality, this is for glucose solution. So we had calculated only for sucrose solution here. So we have to calculate for glucose solution. So for glucose solution, what is the formula for molality? Number of moles by mass of solvent. Right, number of moles is 0.028 here. So molality of glucose solution is, it is not written here, I am telling it to you. Molality of glucose solution is 0.028 divided by 0.095. So that will give this value 0.29. Right? So for glucose solution, the depression or the difference in freezing point, that is equal to molar depression constant, we get obtained 13.97 into molality. Molality means that is 0.29. Just now we get obtained by dividing number of moles divided by total mass of solvent, that is 0.29. So we got the value del Tf is equal to 4.08. That is the difference in freezing point is 4.08. If we reduce this del TF value in the freezing point of pure water, we can get the exact freezing point of glucose solution. That is 5% glucose. So, freezing point of pure water, it has been given there already. That is 273.15 minus the del TF value what we obtained now. That is 4.08 for glucose solution. So, the actual answer is 269.07 Kelvin. This is the answer required. Let me go to the question again. Listen here. A solution 5% by mass of an cane sugar in water has a freezing point 271 Kelvin, and freezing point of pure water is 273.15 Kelvin. Now, by using these two values, we should calculate the freezing point of 5% glucose in water. Right? Again, coming to the solution here. So, the depression of freezing point will begin by del TF, that is freezing point of water minus freezing point of solution. Here, in this case, they had given the freezing point sugar solution. So the del TF for sugar solution is 273.15 minus 271, that is equal to 2.15. That is the del TF for a sugar solution, right? We have to get the freezing point of glucose solution. So for that, we have to use a formula to calculate the Kf value. That is del Tf, that is equal to Kf into F. This is the final formula we have to use. By getting the difference in freezing point, we can reduce this difference in freezing point from the freezing point of pure water, so that we can get the freezing point of 5% glucose. So this is the final formula we have to use. Del Tf is equal to Kf into Kf into M. Kf is a molar depression constant. M is a molality. So we have to obtain these two things: molar depression constant, molality. So molality is quite simple. That is number of moles divided by total mass of the solvent in grams or kgs. Right? That is molality. And for calculating Kf, we should get the del Tf by molality. Molality just now we said. So del Tf value we have to get. For obtaining the del Tf value, Kf is equal to del Tf by molality. Here, the difference in del Tf we get obtained here. That is 273.15 minus 271, that is 2.15. So, by using this one, we can calculate the freezing point of 5% glucose solution in water. That's it. So, two solutions I had given you by using the simple formula and by using the understanding methods. Whichever is convenient for you, you can choose that one. And still, if you're not able to understand, text me in comments. Let me clarify in Tamil once again if you need. Thank you, guys.